In this slide, we will discuss about two scientific facts. The first one is about the Eiffel Tower. The Eiffel Tower can grow tall by 15 cm in summer. One of the reasons that Eiffel Tower is still as dazzling as ever is because it adapts to its environment and all types of weather conditions like wind, cold, rain, heat, etc. Like other metals, iron is sensitive to variations in temperature, and so it reacts to high temperature in summer and low or even negative temperature in winter. When temperature rises, the tower increases in size. This is due to a natural physical phenomenon called thermal expansion. The thermal expansion is when a substance is heated up, its particles move more and it takes up a larger volume. Heat causes an increase in volume, which makes the Eiffel Tower a few centimeters taller. This expansion also causes the tower to tilt slightly away from the sun. The sun only hits one of the four sides of the tower, creating an imbalance with the other three sides. So the other three sides remain stable. This causes the Eiffel Tower to look lean. In this way, the sun's movement over a day can cause the top of the tower to move in a more or less circular curve, so that the measuring is approximately 15 centimeters in diameter. In converse, when cold winter arrives, metal structure contracts and it can lose a few centimeters. The next fact is, when a paper is folded 42 times, it would reach the moon. So let us assume we have a very fine paper which is only 0.001 centimeter or 0.1 millimeter thick. We also assume that the size of the paper is so big that you can fold it over and over as many times as you wish. Initially, you have a piece of paper of 0.1 millimeter thick. For one fold, your paper will have 0.2 millimeter thick. The thickness is similar to the strand of a human hair. For two fold, your paper is now 0.4 millimeter tall, so it is similar to the width of a grain of sand. For three folds, your paper is now 0.8 millimeter tall. It is similar to the width of a pencil tip. For four folds, your paper is 1.6 millimeter tall. So it goes on increasing. The pattern is that 0.1 into 2 power n, where n is the number of foldings. So it will have thickness with this formula. So this is called as the exponential growth. If you fold the paper 17 times, we will get a thickness up to 131 centimeter. This is similar to 4 feet. When you fold 25 times, it would give almost a quarter of a mile. So this type of growth is called as exponential growth. So this slide shows that the variation of the thickness in kilometer to the distance of the moon from the earth. The distance between the moon and the earth is almost 3,80,000 kilometer, which is about 4 into 10 power 10 centimeter. So when we fold 42 times, the thickness of the paper is about 4 into 10 power centimeter, which is almost equal to the distance between the earth and the sun.